Okay. Hello. Hello, everybody. Let me see if I can get this camera going. All right. Hello and good morning. Can everybody see me and can everybody hear me? All right. Thanks. You in-person people using this chat system for the first time, this classroom system, there's a bunch of buttons in the upper left that control the participant list. And then down at the bottom is a mute and unmute button. And if you want to say something, you can say it or get in the chat.
I have a quick question.
Oh, sure.
The form that you have displayed right now, where can I find that in our content?
It's in the Chapter 4 lecture notes. Okay. So in the eLearn system, there's a tab called Lesson, and then there's different tabs in that lesson. Or, yeah. No or. So that's where it is. That's just something I grabbed off of Wikipedia or something, so you could find it there as well. Right. So I have to start by apologizing for this being so, it's going to be unprofessional and chaotic. Sinclair closed everything until noon, which doesn't really affect us, or it doesn't affect you in the class because you can just sign in remotely. The problem is that I have a 1 o'clock class that's not canceled, and this class goes to 12:15. That's not enough time for me to get from home to campus on time, and so I thought I'd come to campus early and just kind of run it solo, but the building is all locked up, and so I'm sitting in my car in the Sinclair parking lot, hoping that my laptop battery lasts the whole time. Fortunately, I'm able to get on the Sinclair wireless network. Yeah, that's why you see this big windows in the background. I'm sitting in my car. This is terrible. Don't tell anyone, but that's just how it has to be because the way the scheduling works. So I hope this isn't too terrible today. All right, let me erase all this lovely artwork. Oh, I can't. Oh, well. Oh, there it goes. All right, so the topic for this week, and the camera keeps crapping out on me. I wonder what's going on there. The topic this week is this idea of joins, bringing in information from multiple tables. And there's lots of different ways to do these joins, as this diagram shows. I said last time, don't try to memorize this. As you do this more and more throughout the semester, it will start to become kind of second nature to you. And if you get some oddball query, then yeah, you can go look it up. But like a lot of computer things, you don't memorize everything. You learn the concepts, and then you can do some internet searching or look in the textbook to figure out the specific details. So what I want to focus on today here is this one in the upper left. This is probably the most common kind of join that you'll do in any kind of database system, and you'll do it a lot in the homework. And this is for a one-to-many kind of relationship. That's the most common kind of table structure that you have in databases. So it makes sense that that's the most common query that you would execute. Let me see if I can do the screen sharing now. All right, can somebody confirm that they can see me typing the word select?
Yep.
Yes, see it.
All right, thank you. Thank you. Oh, I'm surprised this is working as well as it is. Ah, crap. I spoke too soon. All right, let's try again. In the schema browser, upper left on my screen, there is this AP database that we were playing with before. I'd like to use that again to demonstrate some of these joins and how they work. And what I want to look at particularly is take a look at a table called invoices. And let me show you a quick little feature of this MySQL workbench. As I float my mouse pointer over a table, you can see there's this little grid looking button on the far right. And that's a quick shortcut to select all of the rows in that table in one click. Pretty handy. All right, so AP in this sample database stands for accounts payable. So if we're a company, we have to pay our bills. We owe vendors different amounts of money. And okay, this is just not, I'm gonna try it once more. And see what happens here. I'm not gonna mess with the camera for a few minutes. Too many things to go wrong. All right, and then in my invoice table, I can see these different invoice IDs. This is a primary key, something to make each record unique. All right, and now let's take a look at this table called invoice line items. So in my schema navigator, I'm going to select that table and then also hit that little grid button to do a quick select on all of the rows in that table. And we can see this first column here is called invoice ID. This shows what invoice this line item is associated with. So if we take a look at number 12 here, we can see that shows up 4 times, which means this one invoice, invoice number 12, has 4 separate items that were part of the invoice. So I could flip back to my other table, excuse me, and scroll on down and find invoice 12 and see all the information about it. But then I have to keep flipping back and forth between these tabs to see the lines and the line items. So let's do a join to see them both together. So I'm going to open up a new query window here. And select star from and I can't spell. And the screen sharing's going out again. Oh my gosh. This is going to be one of these left joins. It's a one-to-many relationship. One invoice has many invoice line items. And the full SQL syntax for that is left outer join. But The outer part is optional, and so most folks just say left join because we're lazy, save us a little bit of typing. And then I'm going to bring in the invoices table.
Hello?
Hello? Where'd it go? Oh my goodness.
Sorry, I thought your battery ran out for a second there.
Oh no. Huh, okay. Jeez. All right, now it's back. All right, so, and then I use the SQL keyword on to write out that association. How do we connect one to the other? So I'll look at my line items and I can see there is this invoice ID, and I look at my invoices table and I can see there's also an invoice ID. So those are the keys that join this together. I'm also going to use that alias technique because I don't want to type out these big long table names. So I'm going to call this L, short for line items. And I'm going to call my invoices I because I'm lazy, but I don't think it's confusing or unclear. And then I'll hit the lightning bolt to make this run. Oh, it's not invoice ID, it's invoice underscore ID. And let's take a look at that number 12 now. And we can see the 4 line items that were there. But if I scroll off to the right, now I can see the invoice information itself here. I can see what vendor, what invoice number, invoice date. So this is joining those 2 tables together into one consolidated view. And let's further take a look at this vendor ID. I can see there's a number that says what vendor this is associated with, but who is that actual vendor? So again, I'll go over to my schema navigator, highlight the vendors table, hit the little query button here, the little grid looking thing, and I can see my vendors, and I can see my vendor IDs here that correspond to that foreign key in the invoices table. So let's bring in another table. And we'll call that V, just to be lazy. And then the invoice has a vendor ID that matches the vendor table's vendor ID. And we'll make that a little tidier. And hit the run button again. And scroll farther off to the right. I can see the invoice number. And keeping with the right hand scrolling, now I can see the actual vendor names. Great. This is a lot of information. This just keeps scrolling and scrolling off to the right. I've got 3 tables connected together here. And so 3 tables and all of its columns makes for a really wide list. So let's try to trim this down a little bit. And instead of saying select star, instead of grabbing all of these columns. Let's grab just a few. We'll get an invoice number from the invoices table. Let's grab that line item amount and the vendor. We'll see what the name of the vendor is. What's that called? Vendor underscore name. Let's move that down to another line just to make it tidy. And run this query again. All right. This is probably too little information, but it is a nice consolidated view of my invoices.
So when you're selecting data from multiple tables, you'll have to list the table name before you list the field you're looking for in the select.
That is correct,
Okay.
except invoice number only exists in the invoice table, so it's not ambiguous. Similarly, the line item amount only exists in the line item table, so it's not ambiguous. Vendor name only exists in the vendor table.
Okay, so it only applies if they have the same fields from different tables.
That's right, to say which one. So yeah, I just reran the query without the table prefixes, and it also worked just fine. And it's a matter of personal preference. I sometimes like to use them just to be clear. So even if it is not ambiguous, somebody else looking at my query might say, I wonder what that is. And this kind of goes back to the idea of computer programming as well. Sometimes you want to make your code as clear for another person to understand and not just telling the computer what to do. But that's a matter of style. All right. Let's take a look at my invoice table again. I also see that there is this terms column. When you're talking about purchasing in a business environment, the terms are how you pay. And a lot of times companies will have 30 days to pay after receiving an invoice. Or if you're a preferred customer, maybe the vendor gives you 90 days to pay, or maybe you have to pay right away. Let me go to the schema navigator and hit the little grid button here. And we can see all of the terms that are in here. And again, with the primary key to make each one unique, and then the different payment terms that the vendor requires. So let's go ahead and modify our query and bring in yet another another table. So let's bring in those terms. T. And I forgot already what that column was called. Terms description. All right. So let's add that to my select. And run the query again. All right. So net 30, net 10, net 20. All right, and I can keep doing this all day, well, at least for as many tables are in my database. Let me go back to the invoices table. No. Let me go to the line items table. And we can see that there is this account number. When, when you're doing purchasing in a business environment, you don't just write a check. The money has to come from somewhere. And that's what this general ledger accounts is. Companies like to put their money in different buckets so they can budget and manage. And we'll say, you know, we're going to spend $1,000 this year for, you know, coffee supplies, and we're going to spend $200 on paper clips this year, and different things that you buy go in different accounts. And if you go into an accounting class, you know, we got debits and credits and reconciliation and all that. But if I do a query on all of these accounts, we can see, you know, auto license fees and book inventory, building lease, building maintenance. So each purchased item comes out of an account for accounting purposes. So we can bring that in as well. So we can see each line item, what account it comes from. And so it becomes yet another join in this big monster query. And I've forgotten the names already. Account number in the invoice line items, and also account number in the ledger. So GL dot account number, dang it, equal to the line account number. Doesn't quite fit on the screen here. Let's just resize this. And add one more term to our select. Let's grab this account description, because that means more to me as a human than some primary key number. Query's getting pretty big. And if I scroll off to the right, I can see freight, telephone, meals, office supplies, and so on. Try to bring all of this in on one screen. Remember that the white space doesn't really matter with this SQL syntax, so I indented my select so I can visually see which fields are part of the select, separate from the from, separate from the joins. Okay, let's try this camera again for a couple of minutes. So that was a lot of stuff, and it's easy, of course, when I do it. And once you've done this a couple of times, it does start to make sense and become second nature. Notice that we've brought in 1, 2, 3, 4, plus the original line items, 5 different tables all connected together with one big query. So when you go through the the textbook, you can start to see some of the samples that they have in the book. Let me find a good one here. Some of these queries get to be pretty big. And when you first look at them, you say, oh my gosh, that's a lot of stuff. Oh my gosh, look at this. It is even bigger. And notice also I didn't really show you this today, but there's a where and an order by. You can build these giant monster queries, and you shouldn't be afraid of it. If you just take it apart piece by piece by piece, then you can start to understand how the query is set up. Let me go back to screen share here. As you're developing these queries, sometimes it's difficult to get started. And the way I like to think about it, and the way that's probably easiest to get started, is to have your main from part, kind of your starting table. You should usually start with the most specific, the most detailed item in the tables that you're joining. So in this example here, the line items are the most detail oriented. Multiple items have an invoice, and an invoice has a vendor, and a vendor has a term. So go from general to specific. You don't have to do it that way, but that's how I like to do it. And especially when you're getting started, this is a good way to, sort of a, kind of a default. If you're not sure where to go, start at the most detailed. All right. All right, so I'm having lots of technical difficulties here. I hope this is working for you. Let's take a little pause here. Do you have other questions? Anything else come to mind as I go through that?
I have a question. In the homework,
Yeah.
there's a question that talks about running a query that includes two tables that do not share a primary or foreign key. So I'm not sure how to join tables like that.
All right. All right. Am I back now?
Yes.
Okay. I lost my Sinclair network connection, so I'm tethering off of my phone hotspot, so maybe this will be a little more reliable. So Heather, I guess I forgot who that was. Yeah, was asking about doing these joins not on primary or foreign keys. You can join anything. So this on part, any on part can join any two field names. They don't have to be primary keys. So you could join on, the name, where last name equals Smith. Now that defeats the purpose of primary keys because lots of people are named Smith, but you can join on numbers that don't, or not even numbers, on text, on anything. There's somewhere in here there's dates. So let's see here. Yeah, okay, yeah, here's a date. You can join on a date, and I don't know what kind of sense that makes, but the computer will look and find those matching dates and do the join that way. The problem with that is that it's not as fast or efficient. Computers like working with numbers, and if we make our primary keys numbers, then the database more correctly, the database can do this more quickly. For us in this classroom environment, it doesn't really matter, but you could imagine databases at Sinclair that have, tens of thousands, hundreds of thousands of students and classes and payments and tuition and all that. You want those queries to be as quick as they can be. So we usually do the join on those primary keys and foreign keys, but you can join on anything. All right. All right, let's do a little bit more here, and because you're going to need this for the homework as well. So I'm going to open up a new query window here. Come on. All right, so a quick query to see all of my vendors. Great. What I want to show you is union. And so we have selects like we've seen before, and then we have union with another select that follows it. This is for joining together, and I shouldn't use the word join, actually. This is for connecting together information from different tables that might not be connected by a primary key, foreign key relationship. And as a ridiculous example, let's go to the terms description. All right, so two separate selects that, well, let's run it and we'll see. All right, so up at the beginning of this list here, we have all of our vendors. Oh, I don't have the screen share on. Sorry about that. All right, so a select gets one batch of information, and then a union means to join these two together. So when I run this, we can see all my vendors. I'm in the C's right now. Let me page down. When we get down to this WXYZ, we can see the last vendor, Zilka Design, and then we get those different payment terms. So it's one big long column from two separate unrelated tables. And this kind of query in this example here doesn't probably make sense. The one that you do in the homework will be a little clearer. But yeah, this is a way to sort of append or concatenate unrelated or information unrelated by a primary key, foreign key relationship. And as long as the columns are the same type, in this case it's all text, then it works. I could not union a numeric column with a text column or a date with an integer. So in the homework, you're going to be getting names of employees and names of customers in one big long list. And so that may not make sense in, that's a better example of, how you might use a union. All right, so we want to get to generator to generate a customer and employee list in one query. So you'll do the union to make that work. All right. Okay, well, that's not everything. There's a lot of stuff in the textbook, and there's some things in the homework that maybe I haven't shown you, but you can probably figure out. Figuring things out is an important skill when working with any kind of computer system. And let me also say, I think I've said this before, you might not all click immediately. Give it some time. Give it a chance to sink in. All right. Let me, where did it go? All right. Here is the eLearn system, and this has been chapter 4 in the textbook. There is a quiz and an assignment that will be due Sunday night. And before we come back on Monday, maybe over the weekend or however you manage your time, go ahead and click into next week, and we'll see we're going into chapters 5 and 6 in the book, talking about this thing called DML, Data Manipulation Language, which is just like it sounds. It's the language for manipulating this data, which is what these selects have been. So do take a look at that sometime before. And I think that this is as far as I want to try to go with my parking lot setup. So I do want to wind this down then, but before we all depart, are there other questions or anything else you want me to go over in another example? You can get on the mic.
Yeah, I had a question about the Oracle ERD.
Yes.
The orders and employees table don't, like, they're connected, but they don't have a primary key connected to a foreign key. So I was wondering, how are they connected?
All right, let's bring that up here. Um, I'm sorry, Brendan, say that again.
So the orders table and the employees table are connected, but there's not an actual, they don't have like a field that's connected.
So you're talking about this line here?
Yeah.
Yeah. That doesn't really make sense, does it? Why would an employee be connected to an order?
Yeah.
Let's take a look.
It's to track the employee's sales.
Well, let's see here. So orders. Unless that corresponds to the sales ID. All right. That's a lot of screeching. So that might be what they're going at there. Yeah. And you can kind of see the way that these drawings are set up. Let me zoom in a little bit. That these lines do, at least they're supposed to connect to, be sort of positioned where it matches up with that key. So I wonder how old this database is. Salesmen. Do we talk about, saleswomen, sales? Anyway, that's what the connection would be.
Gotcha. And then how do you add a database or table information to a schema?
Like you've got a database already and you want to add a new table to it?
Well, how we just like copy and pasted all of the information from the two worksheets. Was I supposed to, do I need to like create a database around it and then run all that code?
Well, I guess let's take a look at the, where is the, well, you'd have to look, I'm trying to bring up that script here, but you'd have to look and see if the script has a create database or create schema command at the beginning.
Okay.
And I just am not finding. Oh, here it is. All right, so here's the script here, and all of this stuff is just comments, so we don't care about that. So the first thing here is it says create table. So the answer would be yes, you would have to create a new database to go around that, or you could modify this. So you could either do that in MySQL Workbench, or we can just, I have to go into enable editing. No, not that one. this one. So you could just type, in the line before here, create database, just that. And so then that would create the database that the tables would go into.
How would I add the database to a schema? Would it just be like create schema, then create database?
Well, so database and schema are pretty much interchangeable.
Oh, okay.
There are these different dialects of this SQL language, and some systems use the term schema, some use the term database, and MySQL will happily accept either. I think MySQL likes to call them schemas, but it accepts the term database just for compatibility. So yeah, one or the other. All right. Any other questions or comments? All right, well, I'll interpret that silence as a no. That's what I have here for today. So if you want to leave the meeting, you may. Thank you for tolerating all of my technical difficulties. This is just ridiculous that I have to do this, but I hope it was valuable for you today. I'll stick around for a little while if you want to ask questions or leave the meeting, and have a good weekend.